Hi, this is Bill. Now I want to look at this countdown timer that we made. Here it is in operation. Green, yellow, red, and 5 beeps. Now I want to think about this computationally. So it's a problem. A countdown timer is a problem. We want to have a number of sequence of LEDs and then a number of beeps. And before we write the program for this, we need to think computationally about what's going on. And the reason we do this is because a lot of students actually struggle to understand how to tease apart a problem, make it into a solution before they start writing program code. So this needs to happen before program coding begins. For those of you who have got this, and I mean, there are a number of students who really do get this pretty quickly and others who take a little bit longer to get it, that's fine. But I need to sort of explain what computational thinking is. Now, computational thinking is all about decomposition, which is breaking big problems into smaller ones, abstractions, which is trying to find a name to describe a whole group of things, pattern identification, looking for groupings of things, and then we write an algorithm which is made up of sequencing of our decomposed abstractions and patterns and the conditional selection of any decomposed things and abstractions and patterns. And then sometimes we iterate things, which means not just repeating them, but doing them over and over again until we get closer and closer to the result we want. So let's have a look at this countdown timer. I'm going to start with thinking about what can I decompose it into? What are the abstractions here? So here it is again, the LEDs, and then the beeps. So what I've done is I've thought about this as two abstractions. The first abstraction is the LED sequence, and the second abstraction is the beep sequence. So that makes it nice and clear. This is what I'm trying to achieve, is some computational thinking. What are the abstractions? What can I decompose them into? Of course, the LED sequence can be decomposed further into turning on and off LEDs. The beep sequence can actually be decomposed further into repeated beeps. Listen to the number of beeps. So that's just a repeated sequence. And the iteration is, of course, keep beeping until we've done it 5 times. So that's an iteration. And so we can further decompose abstraction 1 into abstraction 3, which is a single beep, and then we can do it multiple times. So here's our overall algorithm. The first thing we need to do is our conditional selection. Is the button pressed? If it's not pressed, keep checking the button until it is pressed. And when it is pressed, do our first abstraction, then do our second abstraction. And this falls nicely into writing functions. Each abstraction is a simple function. And of course, I've done the same for the repeated beep. I've made a single beep function which is repeated 5 times. Now, I hope this helps you begin to understand a little bit about computational thinking, solving a problem before you write the program code. Cheers.